Less than 20 years ago, a remote island in the Southern Ocean became the stage for one of the most dramatic conservation stories in modern history. It all started with a simple but disastrous mistake, the arrival of rats and mice. What followed was an environmental catastrophe few could have predicted. These rodents, left unchecked, unleashed a domino effect that nearly destroyed the island's fragile ecosystem. The place was Macquarie Island, often called the island that time forgot. Located between Australia and Antarctica, this narrow strip of land once flourished with life. Giant elephant seals sprawled across its beaches, while hundreds of thousands of royal penguins waddled ashore each breeding season. Further inland, vast meadows of tussock grass and towering mega-herbs gave the landscape a prehistoric feel. The animals here had evolved in isolation for thousands of years without natural predators. Their behaviors reflected this innocence. Petrels, for example, nested in underground burrows with no fear of attack. But that isolation also made the island vulnerable. When seal hunters arrived in the early 1800s, they brought with them uninvited guests, rats and mice. These small stowaways quickly found paradise. No predators, plenty of food, and endless places to hide. They multiplied rapidly and began preying on the island's native species. Bird eggs, chicks, and even adult birds were devoured. Seeds and sprouts were eaten before they had a chance to grow. Insects disappeared. The finely balanced ecosystem began to unravel. In an attempt to control the rodent outbreak, cats were introduced. But rather than focusing on rats and mice, the cats turned to easier prey, defenseless seabirds that had never learned to fear them. The carnage was staggering. Cats killed tens of thousands of birds each year, hunting not just for food but for sport. Entire species vanished. The Macquarie Island rail and the colorful island parakeet were both lost forever. By the mid-1900s, a new threat emerged. In 1878, rabbits were introduced to provide emergency food for shipwrecked sailors. Left without predators, they bred uncontrollably. By 1968, more than 100,000 rabbits were chewing their way through the island's vegetation. They stripped the land of its iconic plants, digging into the soil when the greenery was gone. Hillsides that had once been lush collapsed into dust. The final straw came in 2006 when a massive landslide buried hundreds of king penguins in Lusitania Bay. Years of erosion caused by rabbit grazing had destabilized the terrain. What had once been one of the island's most important penguin colonies was now a disaster zone. Scientists visiting the island were stunned. A place that had once brimmed with life was now a wasteland. Some of Macquarie's rarest plants existed only behind fences. Several bird species teetered on the brink of extinction. The chain of destruction had spiraled beyond control. Cats introduced to kill rats had decimated birds instead. Rabbits introduced as a food source had eaten the island bare. The rats and mice that started it all continued to thrive, unchecked by any natural predator. What scientists were witnessing wasn't just ecological damage, it was a full-blown trophic cascade where a disruption at one level of the food web sent shockwaves through every other part. By 2007, Macquarie Island had become a global cautionary tale. But it also became the site of one of the most ambitious conservation projects ever attempted. The goal? Total eradication of every invasive mammal, every rat, mouse, and rabbit. Not a few, not most, all of them. It was a massive undertaking with an estimated cost of over $24 million. The plan involved a combination of biological warfare, chemical intervention, and canine precision. First came the virus, rabbit hemorrhagic disease, delivered via carrot bait in the island's worst affected areas. It worked fast. Within months, the rabbit population plummeted. Then, helicopters blanketed the island with over 300 tons of poison pellets designed to eliminate rats and mice. But poison alone wasn't enough. To protect scavenging birds from eating tainted carcasses, teams of workers spread out across the island, collecting thousands of dead animals by hand. Still, the biggest danger wasn't what they could see, it was what they couldn't. Even a single surviving rat or rabbit could restart the cycle. That's when the elite team arrived, 12 specially trained detection dogs and their handlers. These were not ordinary animals. They had been trained for months to sniff out the faintest traces of rodents. One dog, a Labrador named Wags, became the face of the mission. With handler Melissa Houghton, Wags explored every corner of the island, from steep cliffs to underground burrows, searching for signs of life. The dogs covered more than 90,000 kilometers, equivalent to circling the Earth twice. Every positive scent led to an investigation. Every cleared area was marked. And in late 2011, the breakthrough came. Deep in a remote valley, WAGs found the last surviving rabbits, a mother and her young. The discovery was a relief, but also a wake-up call. If one family had survived this long, others could be hiding too. So the search continued. More dogs were brought in. Teams worked day and night. By 2013, months had passed with no new detections. Still, no one wanted to celebrate too soon. After all, it had taken nearly 2 centuries to cause this much damage. Restoring the island would require absolute certainty. On April 8, 2014, Macquarie Island was officially declared pest-free. For the first time since 1810, not a single invasive mammal remained. It was a milestone in conservation history. But the question remained, could nature recover? The answer came faster than anyone expected. Almost immediately, plants began returning. Seeds that had been dormant for decades began sprouting. Tussock grass grew tall again, reclaiming hillsides once stripped bare. The megaherbs, like Macquarie cabbage, began spreading without fences. Even the 2 orchid species, once confined to tiny protected zones, were found growing wild across the island. The recovery wasn't just botanical. The birds returned too. White-headed petrels rebounded. Blue and gray petrels, thought lost from the island, established new colonies. Penguin populations rose. As the birds came back, they brought nutrients with them. Guano enriched the soil, helping plants grow faster. More plants meant better cover for nests, which meant more birds. The island entered a positive feedback loop of rebirth. By 2024, 10 years after the pest-free declaration, the transformation was breathtaking. Scientists found that some bird populations were growing by more than 10% each year. Tussock grass was so dense and tall that researchers had to hack their way through it. Beneath the greenery, penguins carved tunnels like secret highways. And the once rare plants were thriving in places they hadn't been seen in generations. Perhaps most astonishing of all was how quickly it all happened. Experts had predicted it would take up to 50 years for the island to recover. But within a single decade, nature had roared back. Macquarie Island, once a symbol of environmental collapse, had become a beacon of hope for conservation around the world. Inspired by this success, countries like New Zealand have begun applying the same eradication strategies to other islands, including larger, more populated ones like Macquarie, Stewart Island. What began as a local crisis is now guiding global policy. Still, the island's safety remains fragile. Today, Macquarie Island is protected by strict biosecurity. Every ship is inspected. Every backpack, boot, and crate is scrubbed and searched. Specially trained dogs scan cargo for the faintest trace of invasive species. The cost of prevention, scientists say, is nothing compared to the cost of letting history repeat itself. The story of Macquarie Island is one of catastrophe and redemption. It proves that even the worst environmental mistakes can be corrected. That humans, while capable of great destruction, are also capable of great repair. So what can we learn from Macquarie Island? That when we act boldly, patiently, and with science as our guide, we can give nature a second chance. And sometimes that's all it needs. Egypt is one of the most remarkable countries in the world, not just for its ancient wonders, but for its modern fight against the desert. Despite being located in one of the driest and most arid regions on Earth, Egypt is a leading agricultural producer on the African continent. That might seem odd at first glance. On either side of the country lies endless sand, desert stretching as far as the eye can see. The only real farmland hugs the Nile River or spreads slightly into its delta. And yet somehow, Egypt continues to increase its farmland every year. Instead of the desert taking over human settlements, it's Egyptians who are reclaiming land from the desert. And one of their most unexpected weapons in this battle? Dead rice plants. That's right, rice straw. Now, rice may not be the first crop that comes to mind when you think of Egypt. The country faces severe water shortages, its climate is scorching hot, and the terrain is far from ideal for water-intensive crops. But thanks to the Nile Delta and an elaborate irrigation system, Egypt has become North Africa's top rice producer. Roughly 1.6 million acres of Egyptian land are dedicated to rice cultivation, almost 20% of the country's farmland. These fields yield between 4 and 6 million tons of rice annually. Most of it is grown in the northern governorates of Kafr el-Sheikh, Dakalia, Behyra, and Sharqiya. Rice is a cornerstone of Egyptian cuisine, one of the cheapest and most accessible staple foods. It also has economic value as a steady export. But this success comes with a significant downside: waste. After every harvest, rice fields are littered with as much as 4.5 million tons of rice straw annually, not to mention husks, dust, and other agricultural debris. This rice straw alone accounts for around a quarter of Egypt's total agricultural waste, a staggering figure. And historically, most of it has simply been burned in the fields. Farmers often choose fire because it's the fastest and cheapest cleanup method. But those short-term savings come at a high cost. Burning releases stored carbon, nitrogen oxides, and fine particulates into the air, contributing to dangerous levels of pollution. Every autumn, the practice gives rise to what's now known as the black cloud, a thick layer of smog that settles over the Nile Delta and even drifts into Cairo. The Egyptian government has acknowledged the problem. During these periods, air pollution levels exceed safe limits, harming vulnerable populations, especially children, the elderly, and those with respiratory conditions. And while some efforts have been made to limit straw burning, the practice remains widespread. In recent years, however, Egypt has begun to seriously rethink how to deal with rice straw. In 2020 alone, more than 1.4 million tons of straw were recycled. That's a meaningful step forward, both for the environment and for the economy. One major breakthrough is happening in Beira, where a $228 million facility is being constructed to produce wood fiber boards from rice straw. These boards, used for making furniture, construction materials, and interior finishes, represent a high-value reuse of what was once considered garbage. The factory is expected to process around 245,000 tons of straw each year and support Egypt's growing furniture sector. While that's a win, the most surprising benefits of rice straw have come not from factories, but from farms. In recent experiments, Egyptian researchers have started using rice straw as a soil enhancer, and the results have been nothing short of astonishing. In 2022 to 2023, a field trial was conducted in El Noberia, an area within the Nile Delta where the land is sandy and dry. Soil analysis showed that over 85% of the soil was sand with very little organic matter, just 0.41% in the top 12 inches. That means the soil retained little water, offered few nutrients, and was largely inhospitable to crops. Researchers experimented with several irrigation and mulching strategies, including plastic mulch, bare soil, and 2 types of rice straw mulch. The test crop was green beans. The most effective approach turned out to be compacted rice straw mulch. On just 2.5 acres, they harvested nearly 19,800 pounds of beans, while using only half the usual amount of water. The same amount of water on bare soil produced just 13,500 pounds. Why such a big difference? Rice straw mulch works like a sponge. It absorbs and stores water, which is then gradually released into the soil. That keeps the soil moist for longer periods, especially under Egypt's blazing sun. It also reduces evaporation, shields the soil from extreme heat, and improves root growth. But straw isn't just a sponge. It's also rich in nutrients. When decomposed, rice straw releases potassium, nitrogen, and phosphorus, 3 of the most vital nutrients for healthy plant growth. Potassium alone makes up 70 to 80% of the nutrients absorbed by rice plants and helps regulate water and nutrient flow within plant tissues. A lack of these nutrients leads to infertile soil, something Egypt can't afford. But when rice straw is added to the soil, it not only provides these nutrients gradually, it also improves the soil's texture. As the straw breaks down, it creates tiny air pockets that loosen compacted soil, allowing roots to grow deeper and soil microbes to thrive. In another trial conducted in 2015 to 2016, researchers mixed 5 tons of rice straw into a 2.5-acre plot. A second plot received the same amount of compost made from straw and manure. Both were compared to an unfertilized control plot. In every measure, plant height, shoot count, grain weight, and panicle size, the straw-treated plots outperformed the control. Clearly, rice straw wasn't just a waste product, it was an agricultural asset. In some cases, straw is even being used to make biochar, a carbon-rich material that further improves soil quality by boosting its water-holding capacity and enhancing microbial life. Biochar made from rice straw also helps reduce nitrogen loss from the soil and suppresses plant pathogens. Another unexpected use? Papermaking. In Egypt, a small nonprofit called El Nza for Contemporary Art and Development has pioneered a low-tech method of turning rice straw into paper. Soaking, boiling, shredding, and filtering the straw results in usable fiber, perfect for handmade paper products. While not yet industrial scale, this project offers a sustainable alternative to traditional wood pulp paper mills, which often discharge toxic waste that ruins nearby soil and water. Traditional mills release sulfates, chlorides, and even heavy metals like mercury and cadmium, substances that degrade soil health, disrupt nutrient balances, and reduce the land's ability to support crops. Switching to rice straw-based paper could significantly reduce this damage. To make this process even more efficient, Egyptian scientists have developed a method that can extract over 65% of the straw as usable cellulose, more than double the yield of current methods. They've also found that leftover material can be converted into natural insecticides, including compounds that kill mosquitoes and other disease-carrying insects without harming humans. Still, these innovations face real-world hurdles. As one professor from Cairo University has noted, the success of rice straw recycling depends on infrastructure. Farmers need help transporting straw from their fields to processing centers. Without a proper collection and distribution network, even the best technologies will struggle to scale. And there's one more promising use for rice straw that could help solve one of Egypt's biggest modern challenges: electricity shortages. In the summer of 2023, Egypt faced rolling blackouts. A combination of overspending on infrastructure and falling gas production created a national energy crunch. The country's largest gas field, Zohr, saw reduced output, and imports from Israel dropped. Suddenly, homes and businesses were losing power for up to 2 hours a day. But rice straw could help. A 2020 study found that if Egypt used all its annual rice waste in thermal power plants, it could generate around 4,193 gigawatt-hours of energy. That's not a complete solution, but it's a meaningful contribution. Even more exciting is the potential of biogas. In biogas systems, shredded rice straw is placed in oxygen-free tanks. Bacteria break it down naturally, producing a methane-rich gas that can be used for cooking, heating, or electricity. The process also creates nutrient-rich slurry that can be used as organic fertilizer. Whether it's powering a light bulb, feeding a family, or restoring lifeless soil, rice straw is proving to be one of Egypt's most underrated resources. What was once discarded or burned is now being recognized for its true potential. The next step: scaling up. Because while pilot projects, experiments, and local efforts are showing incredible promise, the real impact will come when these solutions are adopted across the country. Egypt still burns a large portion of its rice straw each year. That's not just a waste of energy, it's a missed opportunity. But as more scientists, farmers, and entrepreneurs recognize the hidden value in these dead rice plants, one thing is becoming clear. The future of Egypt's agriculture, environment, and even energy might just lie in the fields after the harvest is done. The deserts of Nevada and Arizona have long defied expectations. In places where nothing but sand once stretched to the horizon, modern cities have risen from the dust. Las Vegas, the glittering jewel of Nevada, was born in the heart of the Mojave Desert. To the southeast, Phoenix emerged in the Sonoran Desert, growing into one of America's largest cities. Both of these urban centers now boast populations exceeding 1 million, and they're still expanding. It might seem like there's no more room for new projects in these arid landscapes, but that couldn't be further from the truth. Not long ago, a massive infrastructure development began taking shape in southern Nevada, right in the harsh Mojave terrain. Bulldozers, cranes, and explosives reshaped the earth. Hundreds of workers toiled under the blistering sun, all working toward a single goal: to build a new highway system that would stretch all the way to Phoenix, Arizona. Why? To better connect the two states, and more specifically, to tie their major cities together with an efficient, modern road system. But this isn't just a story about highways. It's about booming populations, expanding economies, and a critical piece of infrastructure that could change how people and goods move across the American Southwest. From 2010 to 2020, both Nevada and Arizona experienced major population booms. Nevada's population jumped nearly 15%, reaching 3.1 million. Arizona saw similar growth, rising by about 12% to 7.1 million. Along with the people came goods, and lots of them. Every year, roughly $144 billion worth of cargo passes through Nevada. Arizona handles even more, over $330 billion annually. These figures are expected to rise steeply over the coming decades. By 2050, Nevada's freight volume could increase by 55%. Arizona's might double by 2045. Two cities are driving much of this: Las Vegas and Phoenix. Acting as regional hubs, they serve as both final destinations and key layovers for people and products moving across the region. Some researchers even refer to Las Vegas, Phoenix, and Los Angeles as forming a growth triangle, a cluster of cities that are growing rapidly in both population and economic activity. Naturally, all this movement requires a solid transportation network. And in the U.S., that means highways, specifically the Interstate Highway System, a nationwide network launched during the presidency of Dwight D. Eisenhower. Built for both defense and transportation, this system spans over 46,000 miles and connects virtually every major city in the country. Interstate highways are held to strict design standards: multiple lanes in each direction, divided traffic flows, controlled access via ramps and interchanges, and no railroad crossings or traffic lights. This design improves both speed and safety, making them essential for long-distance travel and cargo transportation. On the East Coast, densely populated areas are woven together by a web of interstates. The same is largely true for the West, except for one glaring exception. There's no direct interstate connection between Las Vegas and Phoenix. The two cities, despite being only about 300 miles apart, are linked by U.S. Route 93, a highway plagued with problems. Between 2010 and 2016 alone, over 90 fatal accidents occurred along US 93. The stretch between Wickenburg and the Hoover Dam is considered particularly hazardous. Emergency response times in this area are among the worst in the region. And there are structural issues as well. Traffic lights, intersections, narrow two-lane sections, and dangerous bottlenecks all make the highway less efficient and less safe than an interstate standard road. Recognizing these issues, planners proposed something bold: build a new interstate highway, Interstate 11 or I-11 for short, to replace and upgrade the current route. Signs for I-11 have already begun appearing in both Nevada and Arizona. But this is about much more than new signage. It's about constructing a safe, modern, four-lane highway with overpasses, interchanges, wide shoulders, and fully separated traffic. Importantly, I-11 isn't just about local traffic. It's also part of a larger vision, the Canamex Corridor, a proposed trade route running from Canada to Mexico through the U.S. The corridor is meant to streamline cross-border trade and bolster economic integration between the three countries. But there's a problem. Currently, the weakest link in this chain is right between Nevada and Arizona. Rather than build I-11 entirely from scratch, an approach that would have been enormously expensive, engineers opted for a hybrid method: upgrade parts of the existing US 93 and build new segments where needed. One such challenge emerged in Boulder City, Nevada. Upgrading the section of US 93 that runs through the town would have caused major disruptions and required extensive demolitions. The solution? A bypass. In 2015, construction began on a new 15-mile stretch of highway skirting around Boulder City. Workers dug up vast quantities of desert sand and blasted through rock. Specialized equipment carved a modern road into Mojave. It wasn't just a logistical feat, it was also an environmental challenge. During construction, crews discovered naturally occurring asbestos in the soil, a known carcinogen. To protect workers and nearby residents, the team conducted over 14,000 air quality tests and implemented strict safety protocols. Despite the hurdles, the bypass opened in August 2018. It marked the first completed segment of I-11 and offered immediate relief to traffic previously clogging Boulder City. The opening ceremony was held at a scenic overlook with views of Lake Mead and the brand new highway. Since then, Nevada has continued extending the I-11 route. Starting in 2024, the Nevada Department of Transportation began rebranding other highways, like I-515 and parts of US 95, with I-11 signage. The goal is to eventually stretch the highway all the way to I-80 in northern Nevada, forming a continuous corridor through the state. Arizona, meanwhile, has also been working on its piece of the puzzle, though progress has been slower. Since 2000, Arizona has spent around $500 million to widen portions of US 93 to 4 lanes. Yet, many parts of a route between Phoenix and Las Vegas still don't meet interstate standards. Intersections remain, slowing traffic and compromising safety. The bigger challenge for Arizona is building I-11 all the way from Wickenburg, just northwest of Phoenix, down to Nogales, a key border town connecting the U.S. to Mexico. This southern portion of the project hasn't even broken ground yet, and environmental concerns are a major roadblock. During the environmental review process, Two main routes were proposed, a western corridor and an eastern one. The western route avoids dense urban areas and passes through more undeveloped land. But that creates new problems. It runs close to Ironwood Forest National Monument, an area home to the world's densest ironwood tree population. It's also a habitat for desert bighorn sheep, tortoises, javelinas, and dozens of other species. Critics worry that building a highway through this area would fragment ecosystems, isolate wildlife populations, and increase roadkill incidents. The route could also impact nearby Saguaro National Park, famous for its towering cacti and delicate desert balance. And then there's water. In this arid region, groundwater is life. Opponents argue that road construction could contaminate underground aquifers that supply drinking water and irrigation to surrounding communities, including indigenous lands. The eastern route is more favorable to environmental groups. It focuses on upgrading existing highways, I-10 and I-19, with minimal new construction. The upside? Less ecological damage. The downside? These routes pass through developed neighborhoods, meaning homes and businesses may be torn down. And because there aren't many alternate roads, detours during construction could paralyze traffic. In some ways, this could defeat the entire purpose of building a faster route. For now, construction in Arizona is on hold. The environmental impact studies need to be redone, and public opposition remains strong. Yet the potential benefits of I-11 are enormous. A completed corridor could revolutionize trade between Mexico and the U.S., strengthen supply chains, and finally connect Phoenix and Las Vegas with a fast, safe highway. Even in Nevada, where construction has progressed further, there were environmental concerns. The Boulder Bypass, for example, passes through desert bighorn sheep territory. To reduce collisions, engineers constructed 6 dedicated wildlife crossings, 5 underpasses, and 1 overpass. And it worked. In 2014, wildlife experts fitted GPS collars on 25 sheep to monitor their behavior. The animals regularly used the crossings. Other species like coyotes, mule deer, foxes, and desert tortoises followed suit. Ironically, Arizona had pioneered this idea years earlier. Wildlife crossings built during the US 93 upgrades helped reduce animal deaths dramatically. Before the crossings, about a dozen bighorn sheep were killed each year. Afterward, that number fell, and has stayed at 0 since 2014. So as Arizona looks ahead, it doesn't need to start from scratch. It already has experience, both with wildlife and with highway construction. The question is, will that experience be enough to overcome the legal, environmental, and logistical challenges standing in the way? Only time will tell. But one thing is certain, as America grows, so must its infrastructure. And in the deserts of Nevada and Arizona, the future of transportation is being written in concrete and steel, 1 mile at a time.